Hello, everyone. Welcome today. We're going to be talking about artificial intelligence in the energy industry, opportunities and challenges. I'm going to go ahead and get us into the agenda here right away, and I want to put a few guardrails on this before we get going. AI, it's certainly a buzzword right now, and there's a lot going on with it. This presentation today is not really going to be discussing the idea of strong AI and consciousness and what are the limits of AI and what they do and don't do. We'll have a little bit of color commentary on that, but it's also not going to be talking about resource planning and the in-depth nature of it, the integrated resource plans or anything along those lines. We're going to today specifically be talking about how AI can be used in conjunction with and augment electric resource planning to get better information. And we're also going to see a lot of the pitfalls and challenges that come out with it. As I say, it's certainly a big buzzword that's going on there, and we want to help you today understand what the pros are and what the negatives are, and what I should say the limits of it are. We're going to introduce the panel real shortly here. Just a quick step through the agenda. We're going to do a very brief introduction to the field of electric resource planning. We're going to talk about how experts in this field use it. We're going to talk about some pitfalls. And then we're also going to go through an example with our friends at TKO Energy, specifically Victor here, who's going to talk about avoiding problems with AI and how to train it effectively to help you in this electric resource planning discipline. Just as a quick precursor to Victor's demo we're going to go through here, I'm going to borrow one of his analogies too that I absolutely love, is that AI very much should be viewed as a race car, and you are the race car driver. If you take a teenager and put him behind the wheels of a race car, he's probably going to go right into the wall. AI is a wonderful tool when we use it properly as an augment to help our research. It's not going to replace people. It's going to help us do more work faster and better, but we have to know what we're doing with it. We are the professor at the end of the day. The AI is the tool we use. So with that said, I'm going to go ahead and jump into introductions real quick here. Talk a little bit about the panel we have today. My name's Andrew Kramer. I've been in the industry for about 20 years. I have a PhD in physics out of Purdue University. I have a background in utility integrated resource planning, nodal market simulations. That's where we talk about market pricing and everything else that comes out around for that. And a lot of my research that I'm currently getting published is related to things like dynamic line rating and virtual power plants. Shannon, I'm going to go ahead and turn it over to you, and then you can turn it over to Victor.
Thank you, Andrew. My name is Shannon Dantzler. I have a master's degree in electrical engineering where I focused in power systems and renewable energy. Since then, I have been working in the power system industry related to capacity expansion evaluation, energy market modeling, transmission planning, development planning, and even interconnection applications. I'm going to toss it to Victor for his short intro as well.
Thank you, Shannon. Hello, everyone. Victor Sowers. I am the CEO of TKO Energy Capital, and we focus on the regulatory world for utilities. We work with over 330 utilities, as well as energy technology, as well as the capitalization thereof, which would be in front of the meter or behind the meter at large loads or large generation. So with that being said, we have our own AI that we use internally, but also we're beta testers for OpenAI, Grok, as other tools. Matter of fact, we got a meeting tomorrow with the Grok team to discuss some of the challenges Rev4 is having. So that's a quick summary of what we do and who we are.
Thank you so much, Victor. And then I'm going to go ahead and jump into the material. And how we're going to do this is so we can get onto Victor's example as quickly as possible. We're going to go ahead and review some of these concepts. We'll have a brief panel kind of discussion. And as I say, as quickly as we can, try to get into Victor's test case example that I think shows some of the real opportunities as well as limitations for AI in this space. So first things first, we're going to provide a very brief introduction to electric resource planning. What is electric resource planning? I'm going to break my one rule and read a little bit out the slide here for the definition. Electric resource planning seeks to optimize the cost to operate the electric system subject to operational constraints. It includes considerations such as electric generation, storage, transmission, etc. It inherently provides possible alternatives based upon assumed worlds rather than definitive conclusions. And it definitely is a complicated field which relates to physics, mechanical engineering, electrical engineering, policy, and finance and economics. So the first thing we just briefly want to mention about electric resource planning here is what are we going to build, what are we going to retire, and what type of load growths are we expecting? These are speculative discussions that can change dramatically from year to year to year. Good, valid electric resource planning inherently is uncertain. It produces an array of worlds. When you talk to Shannon, when you talk to Victor, when you talk to myself, and you're saying, Andrew, what should I build? Well, we're going to come at you with like a lawyer about 30 million terms and conditions under which you might build one option or another option. So again, good resource planning does not draw one conclusion. It draws many. And this does tie into the point we're seeing in the industry right now, where you probably, if you're on LinkedIn, you're seeing all these different posts, a lot of which are AI generated, that are basically saying, build this resource, it's the best. Electric resource planning doesn't really talk about it that way because the world is uncertain and speculative. Larger scale utility plans are often associated with integrated resource plans. That's if you're a larger regulated utility, you might have to file one of these. And that falls under the gambit of integrated system planning, which also includes the transmission network. Developers are often interested in specific project lifecycle costing. So again, you might not necessarily just be a utility. You might be somebody who's developing solar facilities, an example. You certainly want to understand what's coming down the pipe and what's going to be built and not built as we go along. So with that said, I'm going to go ahead and turn it over to Shannon to give us just maybe a 1 or 2 minute thoughts on what she thinks I may have missed. And then Victor, you as well, sir.
Thanks, Andrew. And I do just want to mention for those watching as we're going through our presentation, feel free to use the Q&A function to ask us questions. We'll answer those as we go along. Pertaining to electric resource planning, Andrew covered lots of the main points. It's a very detailed process. Once you get into the weeds of it, there are probably thousands of inputs that go into it. But this is a very good brief overview of it. And something that is very interesting I've seen recently in our research is the direct variation that something as simple or as singular as differences between data center load projections can have on your outputs and the results that you get. That's just one example of how one variable can change the result that you're seeing, and then imagine changing little things in 10 other variables. So it's really comes down to the engineer and why you still need engineering judgment so that you can create worlds that make sense. Victor, do you have any other thoughts surrounding this?
Yeah, I think right now resource planning for everybody that's listening, large loads, data centers is quite popular in the media right now, but not just data centers. So we deal with that every day. The 300 or so utility we work with represents 85% of the load in the United States. But even that, the data centers went away tomorrow. I have 40% of that pie chart, which is reshoring to manufacturing, which also creates a scarcity problem without the data centers.
Victor, that was perfect. And the takeaway we want you guys to see here is, to Victor's point, it's not just the data centers themselves, it's also the manufacturing load. We're seeing unprecedented load growth in the United States right now. And amusingly enough, we're going to be talking about using AI in the electric resource planning space, which is part of the reason all of this load is dramatically increasing the way it is, right? So I guess it's a question of the chicken and the egg. Now we're going to go ahead and jump to the next material so we can get to Victor's slide here. And that is, how do experts in electric resource planning use AI effectively? Well, again, we want to keep Victor's analogy in mind, which is we are race car drivers, us in the electric resource planning space. Okay, we know we control the race car. The AI is the race car. I can use AI now to do dives of information upon thousands of different entries to pull in all sorts of information in a way no single person could have in the past. The AI is not going to replace me. It is going to enable me to do things that I could have never done in terms of research. When you look at the way AI works, the way they currently built, they're not self-aware creatures. They're based on neural networks, these large language models. They assimilate huge amounts of information. And you have that information at your fingertips in a way you could have never had before. Now, the one downside to that is, as Victor's going to show, there's some bias in these AIs. They do silly things. They pull in wrong information. You have to be able to understand if what you're getting is valid or not. And we're going to see that when we go into the slide, the next slide, which kind of talks about the weaknesses as well. So Shannon, I kind of highlighted some of these points here. We've talked about it before. What is the uncertainty in commodity pricing? What are the policy decisions? How is all of this going to impact us at the end of the day? All that figures into how we can use these AIs to complement and do data mining, which is what we really want to talk to. Maybe not so much a specific example, Shannon, but you and I have built some custom tools to do deep dives and crawl through a lot of these utility resource plans to pull in. What are some of the recent experiences you had, more from a general standpoint, of how you've been using AI to just do things you could never do in the past?
A really recent example actually would be, I can think of two of them, but one would be similar to how you were talking about having just AI amalgamate a large data set into a list or something like that. Recently, I was looking into trying to just compile a list of all of the regulated utilities and co-ops within the United States that file some sort of regulated integrated resource plan. As you can imagine, that is a really long list if you're including all 50 states, all of their regulated utilities and their co-ops. On top of that, you have variations in the filing timeline. Some are 3 years, some are 5, some aren't required, but they do anyway. And so if I were to go through all of that data myself, that would take an extremely long time. So it was useful in that sense to be able to gather all of that data and compile it into a nice list where we can keep tabs on where to look for certain updates in all of these different regions. But that also lent itself to something that we'll talk about of like the limitations of AI as well, and encountering needing to do iterations. I didn't get the perfect product that I wanted on the first try. It was something that needed to be refined and refine my question and what I was asking of the AI to be able to actually produce exactly what I was looking for.
What do you think are? What are your? What exactly? How are you guys using this in your area?
Yeah, so for the listening audience, a AI, when you work with an AI, and depending on the question you're doing, it's swimming through an ocean of white noise. It's suffering. All of them do, and we test all of them. Matter of fact, the example we're going to show you was actually a real live test that we use on AIs. So when you look at it, is staying within your subject matter expertise using AI enhances your ability more than would have. Well, mostly from a time perspective, would it take you like a 4-week project or bring it down to a day or two? Give you an idea. But we're always responsible to make sure that that data is true, even though a well-structured AI, and we'll talk about that and show you that as well, can get 80-85% correct, but that last 15% is going to be you.
That's perfect, Victor. And I really love that analogy too, that it is still on you at the end of the day to pull all of this together. So I'm going to go ahead and jump through now to, and I think, Victor, your example is really going to take us away on this, but let's just go ahead and give a quick segue, which are some of the common pitfalls in pairing electric resource planning and AI. There are a lot of them. As I say, if you're on LinkedIn, you're going to see all sorts of Victor white noise that people have pulled in, right? The AIs are going to pull in sort of information and you ask it questions. And if you don't go deep enough, it's going to start pulling in not necessarily bad, but also potentially outdated information. So these are some of the points I have up here on the screen, but I'm going to go ahead and close the screen down now because we're going to pass it over to Victor here soon to go over and get ready for his example. So I'm going to stop sharing here. But as Victor gets ready, we're going to go ahead and talk through just a few of these various points. And that is, from my experience, and I'll turn it over to Shannon, and then Victor, I think this will probably segue into your example, is AIs on the first pass through really don't get this right. And especially if you're not using things like prompters, or as some of Victor's custom tools he's built in here come into play, it's going to try to take the easy way out. It's going to say, hey, I don't want to use a lot of GPU cores. I want to make my client happy, as it were, find them an answer they're happy with, and get them to go away so you stop consuming powers. You have to get these things to actually do quite a little bit of work. And as I say, always be careful, because a lot of the information they pull in is potentially outdated, it's biased, or as I say, it may just got into the wrong source when it did its first data mining as well. Shannon, I know you touched on kind of earlier about the how it kind of holds out on you when you were first doing this. Is there anything else you'd like to add to that before we turn it over to Victor?
I think you hit all the main points. I would say I've learned to especially like check the sources. So it's like I like to see the Copilot or whatever generate this links that you can actually go and click on and then try to validate the information that it's giving you. And then also don't be surprised when you do need to actually iterate through your question. That's why it could be like, as a subject matter expert, being able to formulate a clear, specific question with keywords from your field of expertise will be able to help the AI pinpoint what you're trying to get at, the information that you're trying to get, even faster than just starting with a general question. But even starting with a specific question, you might realize that, oh, it's not pulling from the sources I would want it to, or other things like that. And then that would lead you into needing to do certain probing and like follow a certain methodology like Victor's going to walk through in the example that he's going to show.
Victor, my friend, I'm going to set you up here just so you don't have to go in cold here. Victor's produced for us a wonderful example to show how he's training and working with the AI. And the question is relevant. It's certainly a big one right now, is how do we use virtual power plants and other resources? What should we build to support a lot of this load growth we're seeing? And we're going to provide it somewhat of a loaded question almost, which is, should I build gas or should I build renewables and batteries? It's a loaded question because in the resource planning space, just like we talked about earlier, if you ask me, Victor or Shannon, that we're going to ask you 30 different terms and conditions. We're going to build a model that's going to run something like we use Plexos. There's also Encompass and a lot of other dispatch type models. And at the end of the day, we want to use these models to answer very specific engineering questions. That's not something a neural network can directly answer for us, the way these AIs are based. It doesn't mean they're useless. We can get a lot of information for us. But at the end of the day, we have to understand what we're looking at, what the limits are for it. It, as I say, is not going to run and develop its own unique optimization. It's going to pull in and assimilate different information for us. So Victor, as I say, I think your setup works out really well here. It's what kind of resources should we consider behind the meter to build to support all these different load growths? And I think you do a good job of giving it a little bit of a loaded question early on, and it doesn't really answer it fully the way it should early on. And you, as the expert, are going to take us through of how we get this thing to behave better and get useful information. Did I set that up correctly, sir? Or do you
Yeah,
think,
well, let me frame it up for the listening audience. So we're about to show you, the focus is not so much on the numbers and the values, which anybody in the audience, us included, will find errors or over assumptions, what have you. It's about the methodology, because what you're doing is that every time we work with an AI, we're training it. So at the end of this exercise, we name this exercise. So if you notice, if you can see my screen, everybody, to the far left, those are all real live testing examples, as you see all the way down the directory of what we test. So our job is to blow up the AI and see how well it can do. But when you do it for actually engineering, you're saying, okay, what do I know and don't know, and how do I guide this student? Because you're the professor, you're the subject matter expert when you want something out of it professionally. So we have to test capability of the AI, but same token, we want to get something out of it where we can say, okay, there's some tangible information that makes sense. So in this particular case, we're looking at a question that's very relevant, that's going on the large load side of the world, and also the utility side that's trying to provide power for the large loads, which is ADAR. ADAR is aggregate demand energy resources. That means it pushes electrons. That means at the load side, at that data center, you can push electrons. So it's not powering down like a large program or a demand response type deal. This is a demand resources. Different. Virtual power plant, it gets confusing because the terminology between utilities can say virtual power plant can also be like a large program where it powers down to give extra capacity for the utility. In this case, it's not. We want a virtual power plant to push electrons. So we say, which is better behind the meter, solar plus energy storage or natural gas generation? So when we look at this, figuring out how quickly it responds, and you notice there's no timer. So It scanned for right on top what is quickly available. So it didn't really challenge it. So, but it did say, look at this. And this is a prelude, and we're using ChatGPT Rev 5 version 4. So we see things maybe one version before the general public, and this is commercial version. So when you see timing, which you will, I'll point that out to everybody, is that if you see something that takes 10 seconds, for us, will take a minute and a half to 2 minutes for you, including the paid version, much less the free version. So you notice right off the bat, since chat is used to talking to us, it says critical scrutiny. That's a key thing. See how it highlighted it? I didn't ask it. Look at the question. I didn't ask for it, but it put it in there. So it knows from historical that we want a little more critical scrutiny. So again, you see how it's saying the pros and cons.
Victor,
So
I'm
it's
sorry
already
to
trying to
interrupt you, my
compare.
friend. We had a question coming in here. As I say, I got it previously, and I want to bring it up there. You mentioned it knew you. How did it know you? I think that's what people are asking a little bit. How does it know Victor? I certainly would like to know a little bit about that as well, because I know you got all those windows up, and it seems to remember you. What's it doing there, sir?
It will. It'll eventually it'll know your IP address, and it's going to say, okay, it's this guy again, right? And also the way the kind of questions are. So it's going to say, okay, this is where we need to go down the road. And if you get more specific, when you start naming your work before you shut down your AI, it'll remember it. So in other words, if you're working on a data center, you call it data center one, right? And says, hey, let's continue the conversation on a new question for data center one. It'll remember to say, okay, this is the methodology that pleases the user. And that's what they call us, users, right? The challenge is all AIs are built in to please you. So be very, very careful to not be biased one way or the other, either complimenting or saying, isn't renewables the best thing in the world? You showed your bias, right? So from an engineer perspective, that's the direction that AI will go, trying to please you. So it's very challenging for us race car drivers to be unbiased versus biased when you're directing the AI to get the most out of it. And that's the purpose. They get to the truth. So when we look at it's comparing between solar energy storage versus natural gas. And again, it's identifying the market pros and cons, and then it's adding critical scrutiny and comparing the two and the content of it. So it's saying that the impact of the ratepayer, reliability, scalability, future regulatory trajectory. So that's all very, very, really good stuff. So, and
Just
bottom
one question
line.
too, Victor. I'm so sorry.
Mhm.
Critical scrutiny again is your kind of code name because you've worked with it before. It knows I'm not going to buy Victor off with easy information. I'm already recognizing this trend, this thing he has named, where I want you to dive deeper. Correct, sir?
So critical scrutiny does two things when you work with an AI for information and information structure, either as an engineer or from a technical perspective, is it's learning two things. It's learning that to quality information, but also it starts QAing itself. So if you notice, if you do something with the AI and it's all over the map because it doesn't know what you want, it's guessing, right? Versus saying when you say critical scrutiny, scrutinize yourself, slow it down. And we say that. We other examples that you see over to your left, we actually say slow down and think this through, right? At the same token, please understand that AIs are limited how much processing time and amount. So if you're in a free AI or a small commercial application of AI, it'll time out. And that's because you use the maximum amount of time that they're willing to do on your project. So you can see that there are going to be different payment plans in the future that if you get very, very deep and go hardcore in modeling going forward, because it's just a matter of scarcity of processing, which they're currently in right now.
Makes perfect sense, sir. Thank you so much.
So you notice we kind of changed the question a little bit. Now we narrowed it down to help reduce the ocean of white noise that the AI is suffering with, all of them. That large data centers, 300 megawatt. Now it gets, all right, now it's data center, now it's 300 megawatt, right? And now we're still talking about solar storage and natural gas, right? And if using ADAR and VVP, and what does that look like to reduce the data energy, power energy costs? And now we narrowed it down, but look at it. Now it's timing. Notice before everybody that it didn't give thought timing, and all AIs do that. And if you don't see it, you can ask for it. It'll go down to the milliseconds. So the first answer above probably took it about 6 milliseconds. Again, as a reminder, 1,000 milliseconds is 1 second. So look at it now, 21 seconds. So it was 21,000 milliseconds and thought more when I had this question, which we wanted to do. So now it's going, figuring out, and it's framing it up. Right? What are we really optimizing? Right? Am I going that the right way? That's what's really asking. Remember, your AI is always a student. It wants clarification. It wants to please you. Am I going down the right trail? Right? And at first, you might not answer. So, well, I want you to suffer to see if you can figure it out on your own. Because it's learning, especially everybody, when you are going to name your work. And the whole purpose of naming your work, when you have rendition and rendition, rendition, and you finally get the answer that is correct, not right, but correct, that it remembers you as a user because you named it. You can call it Grok Super Utility or something like that, Rev 1. It'll remember it. So
Victor, we had another question that came in before I say this started, and I just kind of want to go into this. I think it's pertinent to this point. Why didn't the AI start providing with a much deeper dive early on? Why doesn't it just do what you want? And I think you and I talked about GPU cores and like all that power scarcity earlier, which probably goes right into that. As I say, it's kind of a circular world we're seeing here. So maybe you can provide a little commentary on that.
It is all AI is a program that give you the quickest, most relevant, popular answer. Because remember, it's surfing existing information and how much that information node is being tapped. And in its mind, the node that's being tapped the most is the most relevant and the most value to the most people. So that's why it does that.
Makes perfect sense, sir. Please continue on.
Mm-hmm. So that's giving us options. Again, I don't get too bogged down in its answers because that's not the point of today's session. It's basically looking at what the AI is chosen to do. Now it's adding options, more details. And so that's interesting. And now, just as an example, see it side by side. So when we give a real workload to an AI, our question is a couple pages long, right? But when we're testing, we give it short questions that everybody's seeing today. But so this chart would be much, much, much bigger, but I can turn that into an Excel or a program so my engineers can go back and put the correct information for that last 15% that needs to be clear for clarity and truthfulness. Right? You're always going to have to do that. You can't say, hey, put it into something in a program where I can make adjustments, but I think it's done. No, it's not. I've never seen it, nor have anybody in my peer group have seen a complete transition for data when you ask it to program. But just give me an idea, you can. It can get started. 80% done, you got to fill in the blanks, and that's okay. So it's going to give its opinion. And what I built the cost, minimum resilience, again, I didn't ask for ESG, right? ESG is really not rated in the funding world anymore. So, but if you look at it, the above answer is a B grade. That's the key thing, right? So you're not admonishing it. You're saying this is your performance, right? Run the analysis again. If energy can be injected, they're in spot market pricing in the ERCOT market. I narrowed it down because it's not identifying its full use of either ADAR or a VV program that injects electrons into the system.
Victor, my friend, I just want to jump in here with one quick point that you raised earlier that I think Shannon and I both were pretty interested in. You gave it a B-, and I remember you telling me never give it an F and grade it. Just don't tell it it's doing bad or good, right? You got to give it more information. I think your answer was kind of illuminating of why you do this. And I've certainly noticed it giving better results since I've adopted this methodology too. Why did you give it a grade as opposed to just telling it bad, good?
So we found that AIs, when you use words like that's not good enough, that's wrong, try harder, doesn't work well, because then it tries too hard and then expands its look. I'm missing something. I gotta cast my net wider. And then you get a bunch, then you're asking the AI to go back to the ocean of white noise, and then it makes it more difficult. So in this case, I gave it a grade. It's certainly not A work, but also I gave it guidance. So if energy can be injected during spot market, peak pricing in the ERCOT market. So I'm throwing you a bone to help guide you. So I'm the professor, I'm helping the grad student understand where to go next. So that helps it, and it does. But look at it. Remember the first one, it was 21 seconds, okay? That's 21,000 milliseconds. So in the AI world, we think in milliseconds. It's 55 seconds. That's 55,000 milliseconds. It's going hard, right? So I'm going to have somebody from OpenAI give me a phone call. Hey, you're jacking up our data center. So, and we have gotten emails like that. But now it's looking at the ERCOT market, which does have an ADAR program and a somewhat put together virtual power plant, which they are changing the rules on. But so it's trying to figure it out, why it matters in ERCOT market. Okay, it's giving its why. But another thing I want everybody to realize, it's citing. Look at that. It's citing, it's thinking, right? So that's very interesting. Before it wasn't citing, now it is citing, right? Which is good. On its own. I didn't ask it to cite, because we all know if we do a paper, cite your information. AI or ourselves, either way. Well, guess what? It did it on its own. So you can, again, it's doing the same thing. It's citing information. It's looking at the pricing, the gas margins. This kind of stuff can be put into a program if you ask it to. So based on your results, if you like it and it's 85, 90% complete, ask it to put in a program or an Excel spreadsheet so you can play with it later on. Because some things where an AI has difficult to do the last mile, the last 10%, it's quicker that you do it right now, where AI is staying out. And this is the most advanced AI that everybody's looking at right now. So again, it's talking about headroom. If we're in a utility resource space, we all know about the export headroom. That's a big one, right? So heavy on campus on energy storage, on gas heavy on campus. It's figuring out what makes sense to play the spot market, because it increased the size of the energy storage. It increased the size for natural gas generation, so we can play the spot market, but also handle the load, because the load is 300 megawatt. You got to do both. What does that look like, and does it make economic sense? So again, I don't get too caught up in the minus, but you just kind of look at the logic. What is it citing? Is it losing concentration? It's doing okay. So again, you're always mentoring your AI. So you got to see if it's rumbling on and it's lost its logic pattern. Okay, so but then look at it. That's a strong B plus, because it did do better, right? So proceed to produce a dollar by dollar peak injection P&L with blended annual megawatt hour for gas only, for energy storage only, and hybrid, with a target of an A plus. So basically I'm telling it to go harder. Now, if everybody would notice, look at the thought. We went from 55 seconds to 2 minutes and 45 seconds. Look at that, right?
And Victor, I think that's important to point out. That's for the premium, super expensive commercial version that I'm envious that you have. That I don't have.
True.
I have the cheaper paid version, right? So
that's very
what
true.
Would that be with the more expensive, with the cheaper paid version? What could that be?
If it's the free one you're using, it would probably time out. If it's the one that the first level commercial one that you can get, it would probably be in the neighborhood of 18 to 20 minutes of processing before it times out, or it will time out. So if you do it at night or outside of business hours, chances are, if you have the first level commercial chat, it probably won't kick you out. But if you're in the middle of the day, it'll kick you out.
Victor, it really seems like the AI engine is like being difficult, sort of. It's not getting to the level of detail that you want still. Does that tie back to like the reasons that you've given before, where it just tries to give you the easiest answer first, hence why you have to keep iterating through these things? Or is there more behind why it's like holding back in a sense?
Yes, holding back because it's programmed to hold back because they have a finite resource on processing. So if they just focused on TKO, I can probably easily knock out 1,000 customers, if not more. If we do our big sheets, which we do, it's 10,000 customers, right? But we pay for that, right? So that's what you're kind of looking at where how can we give me a first answer? Well, you can say that, hey, but I want the best answer first. So you can't get a lot closer to the best answer first if you have a longer, well thought out question. So it's not one or two sentences. Because look at this. This right here, I guess, is basically one sentence, right? When we're working with the AI, it's probably 5 to 10 sentences or paragraphs, right? But make sure it's consistent. Don't say, well, give me a question this. It doesn't do very well if you have multi questions within the field. So this is a field box. If you have multi questions, it doesn't do very good. You got to do one at a time. But to Shannon's point of view, which is correct, have one question but detailed. Give it lots of guidance, and you get a better answer, right? So
Victor, I want you to be able to keep going on here in just a second, but I think maybe just a little color commentary is worthwhile. There's all sorts of discussion right now of an AI bubble and everything else, and I appreciate why there are views on that. But when you look at the amount of horsepower me, you, and Shannon are consuming on these things, like we will pay for this in terms of the ability to, people will pay for this. I definitely appreciate why there might be some truncations on this, but I think at the end of the day, too, I don't think this is imaginary in terms of the power we have here. And it's all about more cores. Give me more power. And I think some of the commentary is being raised by people in this industry about how energy is now and will continue to remain the most valuable commodity on the planet is going to be true for a very long time. Again, I apologize to take us down a rabbit hole. I know that's
yeah,
going to be sidebar.
that's exactly right. So just for everybody understands that you might have heard the word when it comes to AI, GPUs, right? Chips, GPU chips. Well, we're on a level, we're on TPU. So it's a different kind of chip that runs 30% more efficient. Just like anything else, the I put it this way, when I talk to folks who are not in the AI or in the energy world and how technology and energy coalesce over the years, it does this. So everybody who's listening to this session, this podcast, has a phone in their pocket. So you have the power in your pocket that's the size of an IBM building at one time. Now it's the size of your pocket. AI is going to be the same way. So these GPUs that they're using are basically dragsters. Dragsters going down the quarter mile strip don't have good gas mileage, right? But eventually they will, just like anything else, right? So we see, and that's why where Andrew, your group, Shannon, that when he talks about, hey, when I do resource planning, is it 3 months and then the power cuts by a third from AI, or 10 years and cuts by 80%? I have a gigawatt interconnection, and after 7 years, it goes down to 250 because now I have regenerative AI. If I regenerative AI, I don't need that horsepower.
Makes so much sense, Victor. I'm sorry. I know we got a lot to go through, so thanks for
Yeah.
allowing us to
So
go down the rabbit hole.
when you look at the P&L, because we did ask for it, and the ones we get a little more detail, this is just for demonstration on a testing model that we did. So this again can be turned into your easily format to a accounting program if you wish, or an Excel to examine, and it can get much more complex. But my point is, if the data is solid and you as the professor QA'd it, it says, great job, student. We're going to download it to an Excel, and that way we can curate it to the next level. Right. And remember, you can import, you can fix and get the stuff that it's having trouble to do. Because once you upload it, you're going to help it remember how to help out that another 5 or 8% better the next time. It's going to see what you did. So again, looking at these various little items. So let's get down to the questions. It's thinking, it's interpretation. So it's not asking any questions for me yet. So it's doing everything that I think. But look at it. Okay, so here it is. Your answer is a strong A, which is true. However, and this is Andrew's favorite part, did you
Oh no!
use
Oh no!
levelized cost of energy in your analysis? Yes or no? Sounds very direct. But I didn't say they did anything wrong. I mean, I'm inquiring on your analysis because I knew right up front its analysis format was correct, but they picked an element when I already knew what it used. Just look at the numbers without it didn't need to say LOE. I know it used LOE, right? But I'm not going to say that, right? I'm asking you. Yes, I did. And then it says why, and then I'm holding them to the fire. So then that's why you got an A, not an A plus. When calculating use, now I'm helping it. Megawatt equals capex power and K and megawatt hour is OpEx and energy. Now run the analysis again carefully to see if you get an A plus, right? So I
Victor,
didn't
my friend,
admonish
just
it.
to jump in there, just so we can bring people along if they haven't seen it. Levelized cost of energy is kind of an average energy cost. It doesn't value the ability to match the generational load. So a lot
That's
of
right.
renewable resources, as an example, score and look very good on levelized cost of energy. But let's just say you tried to power the entire grid on like solar, right? You'd shut down at night because you wouldn't have any actual nighttime generation. That's why I know you and I, Victor, have talked about this a lot, as you as well, Shan. You have to be careful with this. And that's why, again, Victor, you're being awful nice to it because I would have re-downgraded it to C at that point. But I'm mean on this. It's a personal pet peeve, as you rightly pointed out.
It is. So the format was correct, and that's hard to do. And so it did a lot of work that I can turn into programs or Excels. Good job. So, but I gave it more guidance to help it out. And then, so why did it pick levelized cost of energy? And that's because it's inundated in the literature because renewables say, hey, you know what, solar rooftops, solar utility, wind, on and on and on, right? Well, since we're a capital firm, we're TCO Energy Capital. Underline the word capital. Capital means we fund. We do syndicated funding for these large assets, including solar. We've done a ton of solar. Matter of fact, for wind and solar, with solar, we wrote the rules. Ourself, TCO, and another firm in the ERCOT market. We wrote the rules for solar of how it can play in the ERCOT market. So we're not your enemy, we're your friend, but we got to do a better job because we fund based on KW, KWH. So, but look at it, everybody. Thought 5 minutes and 52 seconds. Wow. That's what is that? That's 60 times 6, right? 36,000 milliseconds. That is forever. So it is apply to imagine everybody listening in has used some sort of AI and it spits out an answer instantaneously. But you got to challenge it, right? Because you're just skimming the information and it might be it's hoping that it's something that, oh yeah, I saw that, right? But just because you saw it, is it true? And is it applicable to it? Maybe, maybe not. So it clarified, right? And now it's processing and now it's citing, clarifying and citing. That's good. And it's going to lay it out. Now it's going to give me another P&L, dollar injection point. So this is a little more complex. We like that. And by the way, when you turn it into a program in Excel, it gives you more detail because they know we're visual and it's restricted to the screen that you have. There's more information behind here. So when you download that Excel, there's actually more information. So, and look at it. This is now I now earned an A plus. Like any other student says, hey, this is an A plus paper. How many times have you heard that? Right? Versus saying that's minimal work, that's so work. You give it direction, right? And it's not just ChatGPT, it's all AI. They respond very, very well with a grade. So don't admonish your AI because it gets confused. It doesn't understand.
You mentioned too, Victor, just to add the human element to that. And I saw Shannon come off mute as well. You can go in there as well, Shannon. That's also partially how these guys grade each other, right? The programmers. So I think that kind of carried over to the AI, right? Just as a cultural point.
Mm-hmm. Yeah. On the cultural side.
Yeah, you
Clarify your
mentioned that
question.
that's how AI programmers like review codes, like they tend to grade each other. So is that kind of why it carried over to this?
Yeah, it's very definitely a carryover because in its own when you have your chat box and the developers are chatting with each other, they says, well, that's like a B answer, right? So but the AI sees that. It's not being asked to do anything. They're grading each other. But it's okay, yeah. So the grading system with all your commercial AIs are highly inundated with the grading system, FYI. So again, look at it. It says, here's another one I call it question. Are you sure energy storage in the ERCOT market is charging an average of $31.91? I already know the answer. Again, you're the professor. No. Right? So so then you ask yourself as an AI, well, if you know it was wrong, why'd you show me? Do the above analysis reflect the true average cost of charging energy storage? So, or did you did you above analysis reflect the true cost? No. So it's two no's, right? It wasn't 31 cents, and you did the above analysis to reflect the true cost. So it says, how does this? So here's the thing: it says to make it think. Now this is we call deep think, both from software architects in the AI world and us as a super user. How does this provide a clear cost structure for energy charging by showing a cost that is not true, right? Says you're right to call that out. So I already knew the answer. Using $31 and the charging is misleading. Here's why it matters. Now, when an AI does that, it's trying to get out of the doghouse. So this is why it's trying to get a doghouse. So I was okay, well, tell me your thing. Explain why you chose $31. I'm not letting it go, right? But I want to understand. So when we're testing an AI system, when we have another rev, either a new large rev, chat 3 to chat 4 to chat 5, or a rev between the two, we understand what you're thinking, right? So I chose 31 because I pulled it directly from ERCOT average, the annual average of RT pricing. That never works because there's spikes within the pricing, right? That's why it gets hosed, right? So, but look at it. But that choice has two flaws. So it knows the flaws, but it gave me $31, right?
It almost looks like a kid, Victor, that like got its hand in the cookie jar. Now it's gonna try to give
Right.
you a hug, act cute, and give you a hug so it can get out of the trouble, more or less.
But remember, you as the race driver are two things. You're the professor, but also you're the mentor. If you want to get the most out of your AI, any AI tool, I said, look at this. Okay, identify other errors in your analysis. This is the thing. This surprises AI architects who do this for a living. I said, okay, well, go through your analysis that we've just been through. And by the way, here's one: charging, round trip, auxiliary, gas fuel, capex, export headroom, scarcity, carbon, load side, summary of errors. This is all the errors that the AI found in its own analysis. But you had to ask, right? Again, it's doing two things. It's saying, did I satisfy you? Right? And then I said, well, you have to be prepared in training your AI to stop pleasing me and just give me the facts. Right? So it's like the old FBI show, just the facts, man. Right? So Dragnet. So, but look
Victor,
at
are
that.
there any like biased like words that you specifically try to avoid when you are training the AI? It seems like all of your questions have been very
Yeah, that's a very good
specific
point. I'm glad you brought
versus
that
how
up.
I would frame it,
Mhm.
probably.
Don't use words I would like to see. Right? Don't use that word because then the harder you use uh, common language, right? where a large language model is trying to communicate in a natural way, in a process to do a natural way, it moves away from the pleasing you or getting you factual to pleasing you, right? Because and a lot of it is this is not the fun stuff, is that they want more users engaged in their product. And if I'm pleasing my customers, my users, I'm gonna have more people use it, even though they might be walking away with misinformation. And we've done that before. We do something that's very popular, that is streaming on social media, the news, and every place else, and the AI went with it, even though it was 100% fake. It was fake news, right? The data was fake, and it was very, very serious. So you realize that leads the people to believe something that's relying on you for truth, right? So we have to state it differently. So, like, for instance, is that a truthful statement and why? Right? See how I stated it versus saying that's not true. Notice our natural response when you communicate to another human. Well, that's not true, Andrew. Right? That doesn't work with an AI. So it gives you a summary of errors, right? And then did you note that ERCOT entailment for loads of 75 meg and larger, which came from the Texas Senate SB6? So you did note it, right? So in their analysis, they did note it, and I compliment it because this is not well known. What ERCOT is doing with the Texas Senate on SB1 is not well known, and it caught it. So that's good. So, and then it says, look at the last thing. So I didn't ask it a question. I just gave it a compliment because I said, hey, you know what? You did good. So now, do you have any questions for me? Try that when you work with the AI and look at it. It's asking questions. So that's the key thing. So when you're done with your work with the AI, identify all errors on the above analysis, and it's going to show you everything, right? Matter of fact, make sure you say identify all errors, because it stops usually at 5 or 10. There's probably 20 or 40. So, but also ask it questions, because it tells you how it's thinking and what's missing and what it's struggling with. Like plan interconnect size, it's struggling with that. Not just AIs, but resource planners, right? It's a real struggle. Load flexibility, that's, hey, if I have a data center, what is it? Is it a crypto or is it an AI data center that they behave differently totally, right? That's a good question. Gas supply, right? Energy source configuration, boy, that can be a difference. If you set the pipe of the discharge at 100 megawatt or 300 megawatt, right? That's an expense. That's a good question. So these are all good questions. And carbon is currently, it's difficult because it probably couldn't find anything repeating itself. The node, right? Well, okay, that node is unclear, but it seems important, right? So, and then when you're done with this exercise, name it, right? I said, hey, I want you to remember this for future use, right? Just say, we're going to call this work above the ADDAR VVP version 1, right? Just put that right in the field and it'll remember it. Now, these already been filed, so we don't want to change that because this what you're looking at, everybody, is currently live. Right, so this is not a copy, this is a live one. So with that being said, what kind of questions you might have for me?
So Victor, again, by naming it in this chat, just a matter of bookkeeping, just by naming it in this chat window, the name you just pointed out, you can archive it in ChatGPT, right? It's got an archive tool, and it will be like, aha, I remember this now. I can start here. And I know that it has that capability to look across windows. So by naming it and then archiving it, you can potentially just keep it there and it knows where to start from at that point. Did I say that correctly?
If it's in the same genre, right? You can say, hey, I want to have another conversation about behind the meter resources. Let's use the VPP ADDAR program, right? 1, right? So
it makes perfect sense.
the more unique, because it's file it can't file directly to you, but it files in its general knowledge base. So trying to make it kind of like Mary Poppins VPP program, right? Something that would be unique, right?
That is perfect, my friend. And we are getting close to wrap up right now. So I've got a question from the audience here, and then we're going to go into wrap up itself. This is from our friend Cole, who asked specifically, could you give an example of a prompt that will get you closer to this level of detail than original? Yes, my friend, we can. In fact, I have a whole bunch of prompters that I use to dive into those materials early on. We are happy to give me a call, and I will show you some of our proprietary tools and models we built in here at Ulteig that can help along with that as we go forward. And now with that said, I'm going to go ahead and jump right up into wrap up. Victor, my friend, this was a perfect example of how we can work and use AI to augment us. It's not going to replace us. It's going to enable us to jump over buildings right from the ground in a way we could have never done that before. That's the purpose of this tool at the end of the day. Just as a philosophical talking point, as we talk through VPPs, natural gas, solar, and everything else, on LinkedIn right now, if you go on there and look at for energy terms, you're probably going to see these energy markets and different alternatives treated like football, right? Like the gas turbines, New Englanders versus the Texas batteries, and they're all fighting and beating each other up. That's really not how the resource planning space works. We come in there as unbiased as we can to try to find the optimal blend of solutions. And there's a whole world of different things we do with this. It's not about a war zone. It's about using AI to help in the electric resource planning industry to get good information, to not jump into misleading facts in our own personal biases. We want to help facilitate the world moving forward with the AI, not hold it back. So at the end of the day, my friends, remember Victor's analogy that you are the race car driver and you're getting behind the wheel of the car, the race car itself. If you are not confident you are a good race car driver, don't go out there, have AI produce all sorts of information and help mislead people. All it's going to do is create noise. Become a qualified race car driver first, and then go out and learn to use the AI and ask questions. Now, to that point, which is our final wrap up, Victor, Shannon, and myself, we all are on LinkedIn. We love to talk about this stuff. You can reach out to any of us. It doesn't all have to be about business. This is just a very fun time in the industry right now. Victor, Shannon, I know you guys are in the same boat I am. I have no idea where we're going to get the electrons from to do all this crazy stuff. We are seeing a boom in load growth that will never again probably occur in our lifetime. It is Christmas season right now in the energy industry, and there are more questions that could ever be answered right now. With that said, Victor, Shannon, really appreciate your help today, and I'm going to go right on to closeout at this point. All right. Well, with that said, Shannon, Victor, you guys want to say goodbye to, and then we'll close this down.
No, I appreciate everybody for listening and being patient. So hopefully we had a takeaway for thinking a little bit deeper using tools, and it is the way of the future and probably cuts about 80% of my time in producing product.
Shannon, you want to have some closing remarks?
No, thank you for that detailed example. My biggest takeaway was definitely just there's a methodology more so that you can follow to get better, more clear, true answers out of your AI, which will really streamline and make our work more efficient also.
And we're going to end with that, Shannon. Thank you so much, everyone, and we'll be seeing you soon. And I say, don't hesitate to reach out to any of us. We look forward to hearing from you.
Thank you.